So in this video, what we're going to do is we're going to continue cleaning up our project a little bit. So unlike the IRPC versus deferred stuff that we did in the last video, there's also a bunch of small changes that kind of accumulated over the time I was working on the R&D project. So I have a list of those, and some are fairly small and some will require a little bit of refactoring. But all I'm going to do is just go down the list and show you guys what I updated. The first one that I want to do is a kind of just a mistake on my part, and it didn't sit well with me, and I should have done this right in the first place. But this sort of miscellaneous cleaning up video is a great place to address that issue, and that issue is I really should have used constants for my roles. So you see here, like for example, in our authorize attribute in our web project, we authorize based off the admin role, and we're using a string literal right there. And that's actually what we did for the entire project. So even if we go into our BuzzMMO data migrations configuration to find our seed method, where we ensure that admin and registered are both always present, I also used a string literal. I want to fix that. I want to put that into a constant. So not a whole lot to say about it, and other than this is just going to be a lot of finding and replacing. So let's jump into base, infrastructure. Oh, I do want to point out that a change like this is definitely something that you would want to do and catch as early as possible, because the more and more we use authorization code, the more code we would have to change to make it actually, well, written well. So yeah, let's jump into BuzzMMO base infrastructure namespace, and I'm going to go ahead and create a new class. It's going to be called roles. So I'm creating this class roles in my infrastructure namespace because I want both the client and the server to be able to do authorization logic. So we're going to put our constants into this class. I'm going to mark this class as static because there's no reason for this to ever be instantiated. I mean, honestly, the only reason we need a class here in the first place is because, you know, in .NET languages, every constant or field or anything has to be inside a class. So let's go ahead and say public. I'm just going to do public const string admin equal to the string literal admin, and then I'm going to do a public const string registered equals the string registered. Just to be 100% certain I didn't get a typo there, I'll go ahead and copy and paste that. I don't think I did, but there we go. Only have to do that once. Okay, so now the fun part. Basically, we have to go and replace every instance, or some instances of admin and registered, with the buzzmmo.base.infrastructure. Now, you could probably do something clever with the find and replace, but what I'm going to do is I'm just going to do a find and do everything manually. One of the reasons is this code is going to necessitate that we add in some additional an additional using statement on some of these files. So I'll just do it manually because I can do that really quickly without having to fight with the find and replace. So let's start off with admin. I'm going to go ahead and I'm going to copy the string literal admin, so that includes the quotes. I'm going to hit Control-Shift-F, and then I'm going to make sure entire solution is checked, and I'm going to say find all. So now what I like to do is I like to just open up the files that I'm going to be changing, or go one by one. It doesn't really matter. There's so few things here that it probably doesn't even matter. First one is in configuration, the place we were just at. That's convenient. So all I have to do is hit Control-Shift-Space, type in roles, and come on. There we go. I meant Alt-Shift-Space. Type in roles, hit dot, type in admin. Okay, I'll just get this on my clipboard to make it a little bit faster. And so we don't need to do anything else in regards to admin on configuration. We'll do registered after this. So now on admin area registration, for this, so this is the area of registration in our web project. So in ASP.NET MVC, this class kind of represents the options for your area. Every area needs one of these. It defines your routes for your area. This is not something we want to change to our new constant, but it is something I'm going to go ahead and convert this over to use the new C#6 get only or read only property syntax. So this is still a property, but it's now a read only property. So the backing field is going to be marked as read only, or there won't be any backing field. I'm stupid. This is just going to return the getter is just going to execute this code. Stuff and things. So let's just go through this. This is just going to be super fun and boring. Do that, hit Alt-Enter, get our using statement. Jump in here. Roles.admin. Jump in here. Roles. Oh, come on, ReSharper. Why you do this to me? Roles. See, that lag, that one like millisecond delay lag that I get is really throwing me off here. But anyway, what about this guy? So I just changed all the authorized attributes for all of our admin level controllers. This is not something we need to fix. That is not something we need to fix. However, in our layout.systeml, we do have to go ahead and change this if statement to use roles.admin. Now, I do believe... Okay, I'm going to fully qualify this one, because I don't want to pollute the Razor files with adding a using statement in them. I don't want to pollute their namespace. And it also looks like we already have a name collision anyway, so that would be irrelevant. So I'm just going to do BuzzMMO base infrastructure roles.admin, just fully qualify it. I usually don't have much of an issue fully qualifying things in Razor files anyway. And then for this, we do not need to change that either. So that's admin. If I do our search again on the literal string admin, the only thing left are things that we want to keep as the literal string admin. Now, registered should be a lot easier. So let's jump back into our configuration, and I'm going to grab this registered string. And I'm just going to preemptively fix this. So I'm going to do roles.registered, and then I'm going to do that. Just do a quick Control-Shift-F on that. And so then we're going to basically just do the exact same process. In this case, roles.register. Let me make sure I did that. Oh, and Visual Studio singing. Come on, you can do it. I'm just having an awesome time with my editor. I did actually just update. There's a new update for Visual Studio that I recommend people go ahead and download. You might notice the Visual Studio icon. Actually, no, it hasn't changed, or has changed. I don't know. Words. Yes, we did do it right here. So let's jump over here. I'm just gonna paste this in. Jump over here. I am going to paste this in here. So again, I honestly don't think the string registered appears anywhere in this entire code base where it should not be replaced with buzzmmo.base infrastructure roles registered. So that was a lot of fun. I mean, not really. Those sort of refactors are not usually that fun, but it is necessary because it should have been done like that in the first place, and the more we use authorization, the more of a pain it would be to fix it later. So let's do one more Control-Shift-F on registered, on the string literal registered, and we only have one instance now. So we have gone ahead and replaced all the other guys. Okay, so now, next up on my list is... I ran into, while working on the actor subsystem, I ran into a couple areas in which I didn't have very good error handling. So I actually added some error handling logic for potential common errors that will make tracking down certain bugs a lot easier. So in particular, I want to go into the client systems namespace, and I want to hop on client systems. And one of the most important methods here that has the potential to fail in a variety of different circumstances, which I should have already preemptively added error handling, but it's this getInterfaceID method. So, of course, the getInterfaceByID method is returned when, or used when the server needs to tell the clients, a particular system on the client, to invoke a method. So this is a great place to catch a lot of bugs that might happen in our system where the server thinks that the client has a particular client system instantiated, but it turns out to not be the case. But then the server starts telling the client system to do all these things, but the client system doesn't exist. As it stands right now, if that would happen, we would get a null reference exception when we tried to invoke the method. I wanted to clean up that error a little bit by adding two cases. First case is I want to make sure it's instantiated and actually is valid. And then the second case is to make sure that this interface ID is actually even a valid thing to be referenced in the first place. So to do that, I'm going to say if systems by interface ID at interface ID is null, that means that interface has not been invoked or not been created yet. Now what I'm going to do is I'm going to say var component equals our component map dot components at interface ID. And then I'm going to say on top of that, if the component is null, then throw a new invalid. Come on, ReSharper. You're not going to do this to me, are you? There you go. Invalid operation exception. And I am going to go ahead and put in, I'm going to use template strings. I'm going to use using template strings on pretty much the rest of the code, and because they're far superior to string.format. And I'm just going to say cannot find component interface ID. Now, the second case, so if the component is not null, what I'm going to do is I'm going to throw in another different exception that's going to say component.type.name is not active. So the difference is this happens when the server tells the client to do something with a component that just has never been registered and doesn't exist, quite likely a very fatal bug, or the client knows about that component, but the server hasn't told it to instantiate it yet. And there are other things that we'll be adding on to this class as time goes on to implement some of the other features you guys saw from the actor framework, but I'm going to leave that to another dedicated video and not put in this. Again, this video is all about miscellaneous stuff. And speaking of miscellaneous stuff, I will be, every time I see uses of string.format in this project, again, not in the Unity project, I will be converting them. And a really handy way to do that is I can probably just go ahead and hit Alt Enter, move it over to the right here, and I can probably just go ahead and say use string interpolation in solution. Let's try that and see what happens. That's a lot of files. But this is a ReSharper feature. It comes from a recent version of ReSharper, actually, where you can apply a particular fix over the entire solution, or the project, or the file, or whatever. So in this case, I'm simply instructing it to update everything to use string interpolation. And I didn't think it would actually take this long, but it looks like it's almost done, so I might not have to pause the video. I'm pausing it anyway. And we're back. All right, so now I don't have to annoyingly point out to you guys every single time I manually convert over from string.format to string interpolation, because now the entire solution uses it. And all the files that were edited came up. I just hit Control-Shift-S to save them all. And we have some little squiggly bugs, but I don't really care. Okay, so next up, I want to do something to our simple serializer. So you remember that guy from a really long time ago? Simple serializer. So as it stands, simple serializer doesn't support IEnumerable, which is unfortunate, because that's something that is going to be very common in the methods that we have, and objects that are returned is returning an IEnumerable of something, and so I want to add support to that. Now, we do support arrays, and we're going to be writing something very similar to our array support, but this will be a fun little adventure in generics, so stuff and things. The first step is, since we have pretty much unit tested this entire class, I am going to go ahead and add a unit test right now. So inside my BuzzMMO tests, base tests, I will be jumping into simple serializer. And what I will be doing here is I'm going to just add a test at the bottom. And test, it'll be public void can read and write IEnumerable. So for this test, what I'm going to do here is I'm going to start off by instantiating my serializer. So I'll say var serializer equals new serializer, or simple serializer rather. And we're just going to do one test case here. So I'm just going to say var enumerable equals new. Let's do a list of let's make it interesting. Let's do a list of component ones. And for here, what we're going to do is we're going to do new component one, passing in a float one of something irrelevant, an int one of something irrelevant, and a string array of new array string. Let's just do 1, 2, 3. Let's copy and paste this, I don't know, twice, why not? And let's change this to float.max value just to make things interesting. Int1, let's do int.min value. And then for the string array, we'll do 4, 5. And for this guy, we'll do float.min value. Int1 will be int.max value. String array will be 6, 7. So we're handling a couple edge cases. I'm taking a bunch of tests and I'm kind of rolling them into one here. If you're doing a production system or anything like that, you would actually be writing multiple tests for this. You would some things you would want to test. You would want to test enumerables of integers, enumerables of strings, and always do your max values and your min values when testing that, because those are edge cases that often break. But then you would also do in a separate, and these would all be separate tests, then you would do a test of a component that is a simple component. Then you might do another test case of a component that contains another component. And then you might do a test where you have a component that contains an array of components or something like that. Those would be the edge cases that would come to my mind to write tests for. But I'm kind of taking all that stuff in the interest of time and just doing one thing here. So to test our serializer, we are going to accept our binary writer delegate. I'm basically just following the exact same pattern that we established in all the other tests here. So I'm going to do BW. I'm going to say serializer write object, passing in BW. Now for the type, this is actually a really important thing here. I'll explain in a second once I finish this. And then for the value, we're passing it enumerable. This is actually really important, what we pass into this type parameter here. We don't want to pass in a type of list of component 1, and we don't want it to pass in a type of a IEnumerable without a generic parameter, a non-generic IEnumerable. And the reason is in the code base, we're only wanting to accept IEnumerable of something parameters. So we're not going to be accepting lists or dictionaries. Well, I might add dictionary support sometime down the line, but we're wanting to make sure that we pass in the type that will appear as the parameter type of the methods that we want to support serializing arguments of. And in this case, IEnumerable of component 1 is how it would appear in the code. So then we'll do our BR test, or delegate, or you know what I'm saying, the reading delegate here. And so we're going to say var read enumerable equals cast to IEnumerable of component 1. So we're making a statement here that we don't care when we deserialize a IEnumerable, we don't care what the backing is. Now, obviously, we're going to be using lists, but when we read them, we should only consider them to be IEnumerables of something, whether they're a list or anything else should not be relevant. So then we're going to do serializer.readObject, passing in our binary writer. And again, this is important, passing the exact same type that we passed into the write method. So now what we got to do is make sure that all of our, the read enumerable is the same thing as this enumerable. I'm just going to do this manually, really quickly, really quick and dirty. I'll just do left iterator equals enumerable dot get enumerator, and I'll say var right iterator equals enumerable dot get enumerator, and then I'm going to say while left enumerator dot move next, or left iterator dot move next, I'll say var left equals left iterator dot current, and then I'll say if not right iterator dot move next. Actually, I'll do this first, make the code a little bit cleaner by doing that precondition on the loop right there. And then I'll say throw new invalid operation exception. So then I'll do left equals left iterator dot current, right equals right iterator dot current, and then I'll just say left float 1 should be right float 1, and then I should say left int 1 should be right int 1. And then for the strings, actually there should be a overload and should that will do the string comparison for me. So it should be left dot string array should. Now I always forget that. Pretty sure it's get equivalent to expects the current collection to contain all the elements of the other collection. Okay, well that works. Right dot string array. Okay, so I don't care about these null checks right here. In fact, I'm going to go ahead and hide these null checks. I'm going to hit Alt-Enter, go down to Inspection option, and then I'm going to go over to Disable Once with Comment, and then I'm going to say Disable for Method and hit Enter. That'll add this suppress message up there. Because, to be honest, I don't really... Ooh, I just found a bug. Thank you, ReSharper. I'm not using red enumerable to get my right iterator. So let's go ahead and make sure that we're using the right enumerables. Anyway, I don't care about null reference exceptions. I don't care about that sort of thing in this particular case, because if I get a null reference exception, that means the test failed by definition, and it will cause the test to fail in our test runner, which is exactly what we want. So, yeah, stuff and things. This code's pretty straightforward if you haven't done any of this sort of thing before. Really, to compare two iterators, or two enumerables, this is one of the more straightforward ways to do it. I'm not doing any disposing, but I'm not doing any disposing because I know that both these objects are going to be lists, and I don't really care about them getting disposed. So let's go ahead and run this test. It should fail. Not entirely sure what error message we're actually going to get from the test, but it should at least be some error. I do have two errors in one file. Let me, oh, I made a syntax error. There we go. Let's fix that real fast. You guys didn't see that. So we have an error, the exact thing that we wanted. We have cannot write IEnumerable of test component, and that error, if we look at the stack trace, is coming from simple serializer line 135. So let's jump over to simple serializer, jump to 135, and we see that we get this error when we try to write simple and we don't recognize the type. So write simple is only supposed to be used for primitives, so let's fix that. I'm going to jump up to where write simple is invoked from. It's invoked from write object, and we notice that it gets invoked when we're doing a nullable value type, or if it's not an enum and it's not a custom serializer and it's not an array. So to fix this code, really all we have to do is add a check in here to see, is the type that's being passed in, is it an IEnumerable of something? If it is, extract the type information and then write it at similar to how we wrote the array. So write out the length and then write out the individual objects. So the easiest way to do this is I'll do this check. It doesn't matter where I do this check. I guess I'll do it after the check for is nullable value type. I'm going to say else if type dot is generic type. So are we a generic type? And type dot get generic type definition equals type of IEnumerable, and then we're doing what's called an open type here. So this is an open generic type, and that means we have a generic type that requires generic parameters, but we're not supplying those arguments. So we just have the empty brackets here. I believe the only legal place in the entire C# language where you can represent an open type or represent a generic type without providing arguments to them is inside of the type of operator. But by doing type.getGenericType definition, it's going to return the open form of the generic type. In this case, the IEnumerable with no parameters. Also, this method will throw an exception if the type is not a generic type, which is why we have to specify that first guard right there. So now we know it's a IEnumerable. Now, fortunately, we can work with this without using reflection, because IEnumerable of t inherits through interface inheritance, not class inheritance, obviously, inherits from the IEnumerable non-generic type. So we can extract out the non-generic IEnumerable and work with it in a non-type safe way. But that's what we have to do here because, well, we don't know what type parameter was used. So I'm going to say var enumerable equals cast to IEnumerable, and I'm going to have to go ahead and import this from systems.collections, so that using statement just appeared at the top of the file, and then we're going to do object, or value is what I called it. So now we have a non-generic IEnumerable that we can use. The next thing that we need to know, or let's see here, the next thing that we need to know, I'll just go ahead and extract this out now. We need to figure out what type was used for that generic parameter. So in other words, we need to know what the user specified or what the programmer specified in those brackets. So to do that, it's pretty straightforward. I can simply say item type equals type dot get generic arguments, and this will return an array, so I can index it at 0. And that's because there's only going to ever be one type parameter or one type argument in this type, so we can just safely use the first element. So next up, we need to get the count. So unfortunately, we won't be able to use IEnumerable.count because the count extension method from link does not apply to the non-generic version of IEnumerable. Fortunately, though, it's very easy to get the count. All I have to do is say cart, var count equals 0 for each var item in enumerable count ++. Now, I do want to point out, though, it is complaining about me on this for each loop. It's going to say you can convert it into link, and you can. That's because you can use the cast or the type link method to convert the type parameter into something else, but I don't want to add that extra overhead. I'm just going to do that. We could also, we could even add an optimization in here. If you actually look at the count method's definition, this is just an interesting piece of trivia that might save you some cycles in the future. If you actually jump into the definition of count, so I just put my mouse cursor there and hit F12, and now ReSharper is going to go and decompile this for me. If you look at the actual definition, what it does is it'll actually attempt to cast it into an I collection. And if it can be an I collection, then it just immediately short circuits and returns the count. Otherwise, it goes and it loops through the entire enumerable. Now, I collection, I do believe, it does not, unfortunately, does not have a non-generic form, which I somehow forgot about. Actually, I'm interested in this really fast. Give me one sec. There's probably a faster way to do this. But now we can do IList to do this optimization. And there is an I collection, a non-generic I collection. Okay, good. So what we can do here is for our count, I can just say var count equals 0, and then I can say var collection, or how about maybe collection? Var maybe collection, because that is a little bit more readable to me, saying that this object might be this type. Enumerable as I collection. If maybe collection does not equal null, then count equals maybe collection dot count. Otherwise, for each var item in enumerable count ++. So that'll save us a few cycles. Anyway, I just wanted to point that out as a little bit of trivia for people who might have not known that about how link works. Next thing we do is we write out our count. So write count, just like what we do with our array. And then after that, we just write out each item. So for each var item in enumerable, write object. Now we want to do write object and not write simple, because write object will recursively invoke this method in case the type of the item was something like an IEnumerable. So let's say you had an IEnumerable of an IEnumerable, or in our case, we have in our test we have an IEnumerable of a custom type that implements the iCustom serializer interface. So for here, we just write object, we pass in our binary writer. Type is going to be item type, and value is going to be item. And that's it. I'm going to go ahead and ignore these errors. So I'll go ahead and click on that, or these warnings, hit Alt Enter, move down to inspection options, move over to disable once with comment. I'm going to disable this for method, and I'm also going to do this warning for multiple iterations of, or enumerations of IEnumerable. I'm going to say disable for method. Yes, I know sometimes it is possible that will cause issues when a method accepts an IEnumerable, but it iterates over it multiple times, especially if that IEnumerable came from something like a database call, because that database call will then be invoked twice. But in this case, the kinds of stuff that we are going to be passing in, and as long as we're vigilant, we don't have to worry about that causing any performance issues. But anyway, I mean, what I could do is I could iterate over it once, save the save writing object for the items, save that into another buffer. So I instantiate a whole nother memory stream and a whole nother byte array buffer, and then copy that buffer back in. But because we're in general not going to have a significant amount of items being passed over the wire, and these methods might be invoked many, many times, I don't want to add that additional performance cost. And again, the simple serializer is something we're only using temporarily until we write a better implementation. Anyway, I'm just going to go ahead and rerun the test on my other monitor, and I'm sure it's going to say something now about how it can't read. No, it's still saying cannot write. So let's see what we did, or what I did wrong here. We have type is generic type, get generic type is IEnumerable. Make sure the test is correct. It is. So what I'm going to do here is I'm going to set a breakpoint, and I'm going to hit debug on the test window. And let's see if it even hits this this block. It should hit this block. I don't see why it wouldn't. It does. So I'm just going to hit F5 to see where that exception is even being thrown from. Cannot write. Let's see. Oh, that's just a really bad... Yeah, okay, that's just me messing up. This should not say cannot write, this should say cannot read. And Visual Studio is frozen, because of course it is. Cannot read type full name. That's just me messing up. Okay, so now let's do the opposite. Let's do the actual reading of the object. So it's, like I said, pretty much the opposite. For consistency, let's see where we did this. We did this right after IsNullable value type, but right before isArray. So let's do the same thing here. I'm going to preemptively add a... well, I don't need to add an else to that, because we're returning immediately. I'm going to say if type is generic type, and type get generic type definition equals type of, lots of types here, IEnumerable of nothing. So now what we do is we need to get our element type. I'm just going to extract that out there. Maybe to be consistent with naming, I can do item type. But then on the array, I use element type. Whatever. Item type is type dot get generic arguments at 0. And the next thing we do is let's get our length. So our length is going to be reader.readInt32, because that's the type that we use to pass in the count. Now the next thing I have to do is I actually have to go instantiate an object, and I'm going to be using a list for this. And I'm just going to use activator for this. So I'm going to say var list equals cast to iList, iList being the non-generic form of list. Activator dot create instance. And so to create instance, type of... Now this is where things get interesting. We're going to do type of list, but we're going to use the open form of that. And then we're going to say, after the type of list, we're going to say dot make generic type, and then we're going to pass in item type. So we're instantiating a type that requires a generic type parameter by making that generic type at runtime. Well, it'll cache the type that it makes for future for the future whenever you do this, so you don't have to worry necessarily about the performance other than the first hit. But this is actually how .NET generics work in general. Like, the actual type list of int is not the same type as list of float. They're two completely different types. You have to take the open type, and then you have to apply the type arguments to it to make a concrete type, a closed generic type that can actually be instantiated. And then after we instantiate it, we go ahead and then cast it into an iList. So then all I'm going to do is say for var I equals 0, I smaller than length, increment I. So then we're going to say list.add, and for the object, we're going to pass in read object, reader, item type. And then we're going to say return list. So, yeah, I know there's a lot of boxing going on, but that's kind of the problem with this. One of the biggest problems with this serializer, honestly, is all the boxing that we're doing. But, again, we'll fix that later, especially when we have more data where we can actually profile this compared to an alternate implementation. Anyway, that should fix it. So let's hit run. And it succeeds. So let's go ahead and run all of our tests. And we see green all across the board. So yeah, so not a whole lot of code added, but we now support IEnumerables. So that's always fun. And I think I'm going to go ahead and end the video here. There's more stuff on my list of things to do, but this video is kind of getting a little long. So we'll see you in the next one.